Sorry, Abby. So, yeah, the whole like mic thing. Yep, figure it out. I think I started the video. Yep, there we go. Sorry, Abby. Oh no, that's all right. She's smart. She'll figure it out. All right. So Freddie brought up a good point. She said that Miss Hansen said that she'd never really seen slope fields, and while that's correct, differential equations piece. So the trend within. Do you guys know the difference between a Bachelor of Arts and Bachelor of Science?
One's art, one's science.
Good, excellent. So if you go to a school and you get a Bachelor of Arts degree, you're going to take more kind of writing classes. If you get a Bachelor of Science degree, you're going to take more science and math classes. So without a doubt, within a Bachelor of Science degree, the calculus programs want you leaning more towards a differential equations approach. So this is becoming more popular to start teaching to prepare you for a DiffEQ course, especially for those who are studying to be engineers. So, all right, that's the general.
Who's being an engineer?
Who's not? That's the bigger question. Let's go to particular. In order to find the particular solution, what do I plug in? 0 for what? X and so I've got 4 for y and I've got 0 for x. So c times e to the 0 cubed over 3. And what is 0 cubed over 3? 0. And what is e to the 0? 1. So you get 4 is equal to c. So as we see 4 is equal to c, we therefore have y is equal to 4e to the x cubed over 3. So we figured out that constant that goes out front. Is everybody okay with that? This is your particular solution. Good work. We've got one left. Taya, did I see a question there? Okay. That's all right. I've got it. Gotcha. All right. Last example. And by the way, we're kind of doing the 50% study of this stuff. We're gonna call the AP exams bluff on this and say they're not going to go to the more difficult 50%. I've definitely seen some differential equations on the AP exam where we haven't covered how to do them, and we're not gonna worry about that. So we go to our last one. Oh boy, this looks complicated. Any thoughts?
Subtract 2y.
Okay. I like Alex's idea. He wants to subtract the 2y. The problem is you can't have something plus or minus a dy. It's got to be multiplied or divided by a dy. So in this situation, I am going to divide both sides by 2y over 1. I get 1 over 2y minus 1 dy. And then I'll multiply the dx over, so a 1 times dx. So everybody see how I come up with that structure? Okay. So this is going to take a little bit more work, but let's do the right side first. I'm going to take the antiderivative. So what do you get on the right-hand side? X plus a constant. And then I quick want you to talk with a friend for about 30 seconds. What do you think is going to be the antiderivative of that? Just talk. Go.
Oh.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and done. Anybody come up with that? Okay, and unfortunately that's not correct. It's going to be that, okay? And so I'll show you why, and so hopefully you can then make the prediction in the future to understand. If I want to determine the integral of 1 over 2y minus 1 dy, I'm going to say that u is equal to 2y minus 1. And so then du is equal to what? 2 dy. Do you have a 2 dy? So I get 1/2 du is equal to dy. So notice where the 1/2 comes from. I have my 1/2 du, excuse me, dy is gone. We've changed our variables. And what remains now? 1 over u. And what's the antiderivative of 1 over u? So see how you have the natural log of the 2y minus 1 and see how you have the 1/2? Do you see how I saw that we were going to end up with a 1/2? Okay, so I made that prediction. Sometimes people can just see that and write it down, 1/2 natural log of the absolute value of 2y minus 1. And sometimes people can't see that, and you got to set up the substitution. Honestly, when it comes to AP exam, I see people's free response work. I don't see them setting up substitution. Either they see it or they don't. So I'm just saying that's what I see. So okay, all right. I got to solve for y. How are you going to do that? Times by 2, good. Natural log of the absolute value of 2y minus 1 is equal to 2x plus 2c. And then, create a base of e. So I get the absolute value of 2y minus 1 is equal to e to the 2x plus 2 times a constant.
And that shouldn't, it has to be connected to it. Like, you can't just write plus.
Definitely. Yep. And e to the power, is that going to be positive?
Yep.
So what can I do? Get rid of my absolute values. So we got 2y minus 1. What I really could do here is rewrite this as e to the 2x times like e to the 2c, which is just a constant, right? So the way that they would probably write this is 2y minus 1 is equal to a constant times e to the 2x. Like this thing here, that thing here is just a constant. It just ends up being some other constant. Yes? You could just put a c there. Either way, you're just going to get a constant out front. Okay? There's all sorts of different ways to represent that constant. And then what are we going to do? Yep, so 2y is equal to c e to the 2x plus 1. And then we're going to divide by 2. So y is equal to c e to the 2x plus 1 all over 2. And that is what we call our general solution. This problem that we're doing right now is straight from an AP exam. So this is identical to an AP exam problem that we did. Well, we haven't done yet, but that was done a couple years ago. So how do I find the particular? Plug in what and what? 0 for x and... So 0 is equal to... What? No, 4 is equal to... 4 is equal to some constant times e to what power? 0 power plus 1 divided by 2. So I want to solve that. So I multiply both sides by 2. I get 8 is equal to e to the 0 is 1. So some type of constant plus 1. So what's the constant? 7. So that means that our particular solution is y is equal to 7e to the 2x plus 1 all over 2. That is our solution, particular. Not too bad. If you notice, the study guide that you were handed is just like a front and a back, and then a front, and then just 2 problems. So it's not even 2 full pages front and back. So I will post the answer key to the study guide as well as this worksheet right now. Again, my apologies, Abby. We are so sorry. Most people are sorry. Esther is laughing about the situation. Esther is taking joy in your struggle. Is she not laughing right now? Yeah, she is laughing. She's laughing. Totally inappropriate, Esther. Totally inappropriate.